So we'll make a quiz. We'll start a quiz on velocity selector. Okay. From a bunch of, suppose you have a bunch of charged particles, and the charged particles are moving with various speeds or velocity. So by velocity selector method, you can select some of the charged particles which move with constant velocity. Okay. And this method is very useful, and we will start a quiz on this. So velocity selector method was first employed by Thomson in 1897. The first question is, velocity selector method was used by Thomson to determine what? Charge by mass ratio or mass by charge ratio? Okay, it is the charge by mass ratio. You remember, it is the charge by mass ratio. In mass spectrometer, what you do, we separate the charged particles, that is the ions, by using the charge by mass ratio. The mass spectrometer is based on the principle of velocity selector or mass selector. It is the velocity selector. By velocity selector method, we can separate the charged particles or ions in mass spectrometer. The third question is, in velocity selector method, a charged particle is allowed to move in combined electric and magnetic field. Remember, in velocity selector method, a charged particle is allowed to move in combined electric and magnetic field. So can you tell me, the electric and magnetic field, they are parallel to each other or perpendicular to each other? Fine, they are perpendicular to each other. Remember, in velocity selector method, the charged particles, they are allowed to move in both electric and magnetic field, which are perpendicular to each other. Next question, in velocity selector method, we adjust the electric and magnetic field such that the force due to electric field, whether it is equal to the force due to magnetic field or it is not equal to the force due to magnetic field. That means we should equal the electric field with the magnetic field, or we should not equal the electric field and magnetic field. The answer is, the electric field and magnetic field must be equal. Okay, we adjust the electric field and magnetic field in such a way that the force due to electric field must be equal to the force due to the magnetic field. Next question, in velocity selector method, the charged particle moves with constant velocity or variable velocity? Fine, the charged particle move with constant velocity. Why the charged particle is moving with constant velocity? Because the force due to electric field is equal to the force due to the magnetic field. When the two forces are equal, then the charge will have constant velocity. Okay. Next question, In velocity selector, electric force on charge particle is equal to the magnetic force on charge particle. What is the electric force due to electric field? We know it is charge times the electric field. Remember, the force due to electric field, it is charge times the electric field, Q into E. Then what is the force due to the magnetic field? Basically, it is the Lorentz force. It is the Lorentz force, Q V cross B or Q V B. If you take the maximum force, Q V B. So when the force due to electric field is equal to the force due to magnetic field, QE must be equal to QVB. Then what will be V? V will be equal to, yes, E divided by B. Electric field divided by the magnetic field. So if you divide electric field with the magnetic field, then you can find out the velocity of the charge particle. You can select the velocity of the charge particles which are moving with constant velocity. If you have a bunch of charge particles, out of this bunch of charge particles, you can select which charge particles are moving with constant velocity by using velocity selector method. So these are the questions. These are the questions which will be asked to you in the examination. So you should remember these questions. Okay.